Assalamu alaikum. How are you guys? Welcome to this quick tutorial on calculating failure rates and availability for compressors. We will be using one brand X to demonstrate how you can easily calculate these key reliability metrics. In this slide, we have a compressor brand X. We bought this compressor from the market some time ago with the following features. Capacity is 3,000 horsepower and the performance for this compressor is less than 3 failures per year and availability is 98.5% or better. So what you need is to estimate the current situation from reliability metrics point of view. In this table is analyzing the event rate, which refers to how often certain failure events occur over time, typically expressed in events per 1 million hours. Key terms here in this table, available events are the type of failure or operational issue that the compressor can encounter. So we have here in the second column some type of failures. We have fails to start, fails while running, high vibration overall, and so on. Also, we have the next column, the number of events, the number of times each failure event was recorded in the study. The next one is selected analysis. In this case, is event rate. We take the event rate to estimate the reliability metrics for this compressor, which shows the frequency of failures. The unit of measurement is 1 million hour. And as you know, the greater the study time, the better the result. This means that the failure rate is calculated per 1 million hours of compressor operation. We see here three columns: lower estimate and mean and upper estimate is the last one. The lower estimate represents the conservative prediction, assuming the fewest failure. And the mean, as you know, is the average rate for failure based on collected data. The upper estimate is more aggressive prediction, assuming more frequent failures. And in the last section, you can take a look for confidence limit is 90%. That suggests that you have a 90% chance the true event rate lies between your lower and upper estimates. In this slide, we have a table which shifts the focus from the event rate to time to restore, meaning how long it takes to restore the compressor to full functionality after each type of failure. The key terms, as you see, time to restore. Time to restore is the amount of time required to fix the failure and get the system back online. And you can see the available events as we illustrate in the previous table. So now what we should do here is calculating the weighted sum of restoration time. We multiply each restoration time by the corresponding number of occurrence. We take the two numbers here, 5.8 multiplied by 24, which equals 139.2, and the second row is 96 multiplied by 30.5 equals 2,928, and so on. And after that, we add these values together, and the total weighted sum of hours is 4,018.8 hours. And as you see, the number of events, the sum of number of events, 156. So finally, the aggregate time to restore is like the mean time to restore. We make this calculation by 4018.8 by 156, which equals 25.79, as you see here in the last of call. First, let's calculate the number of failures per year for brand X. We start by calculating the mean time between failure. Mean time between failure for compressor X or for any equipment is the total operating time divided by the failure rate from the first table we have. Now we calculate the number of failures per year by dividing the total hours in a year, which is 8,760, by the mean time between failure of 1,800.6, as you see in the slide. So brand X experience approximately 4.87 failure per year, which is far from our target 3 failures per year, as we see in the previous slides. Next, let's calculate the availability for brand X compressor. To do this, we multiply the number of failures per year by the average downtime per failure, which for brand X is 25.79 hours, as we see in the second table. Now we subtract the downtime from the total number of hours per year, which is 8,760. So the brand X has availability of 98.6%, which is suitable for our previous target of 98.5%. So the conclusion for our compressor, it meets the specification for availability, but doesn't goal for performance. Thanks for watching. Be sure to stay tuned for more tutorial on variability metrics.